Hi everyone and welcome back to another video. Today we're going to learn about version control using Git. So version control is about tracking and managing changes that you make to source code. In a typical team, you're going to have a lot of developers writing code in parallel. And as these developers are writing code, one might be writing a new feature, another might be fixing a bug or something, another might be introducing a bug. And without any form of version control, that's going to cause a lot of conflicts, especially when you've got code that's kind of all over the place. You've got a code base consisting of many files and you're not all just working on your own isolated files. So consider a simple case where, two developers might pick up a file. That file could be anything. It could be a code file, it could be a picture of an elephant or something. They make their changes to it, they modify the code, they alter the elephant in some way, and then they attempt to write that file back to the code base. However, both those developers picked up a file at a point in time, and then they might make conflicting changes. So how do you reconcile that? And that's what version control is useful for. And version control is also useful for just tracking the changes made to files. It's useful to be able to see snapshots of the code base at any particular point in time so that if you break it, you can always roll back to it. Now, one of the things that facilitates this version control is Git. So Git tracks code changes by means of snapshots, which are referred to as commits. And this provides good traceability and the ability to go back to previous snapshots if you need to. Branching is also possible, where a developer or a set of developers can work on their own copy of the code base without interfering with the main copy. They can, produce their own changes in isolation. They don't have to worry about anyone else really. And then there is also this functionality to then merge this code back into the main code base. Now, Git stores files in a repository, which honestly is nothing more than just your code base plus some hidden files, which is usually in a folder called .git, which you can't see normally. Now, with Git, there exists a remote repository, which is hosted on some kind of service, like GitHub usually, and that acts as the central code base, basically. And developers also have a copy of that code base as a local repository. And basically you can keep these in sync with each other. We can pull content from the remote repository into our local repository, make our changes, and then push it back if we need to. So to start with then, I guess, we need a local repository, right? So we have a couple of options. If we have existing files on our computer, we can instantiate a repository using the git init command, and that creates our local repository. With this kind of workflow, basically you start by creating the local repository because you happen to have code on your computer already. We could then separately make a remote repository on GitHub, for example, and connect the two using the git remote add command. However, the most common starting point is to clone an existing remote repository, one that's hosted on GitHub. And that's done simply using the git clone command. This is the most common type of workflow, to be honest, where you're coming into a team and you're cloning the existing work that's there and then building off the top of that. Or even if you're just starting a new project, it's more common to create a repository on GitHub first, which acts as your central code base, and then clone that down as and when you need to. Now, once you've cloned a repository for the first time, it's important to note that you don't need to clone it again. Once you've cloned it, that link is essentially always established between the local repository and the remote repository. The only thing to bear in mind is you obviously might have other people on your team or other people who are using that remote repository, and they might be making changes to it as well. So in order to be kept up to date with the latest changes that are happening on a particular branch, while you're on that branch, you need to use the git pull command. And we'll talk about branches shortly. It's important to use git pull as often as you can, just so your local repository is always kept up to date with the contents of the remote repository. That way, while you're coding, you're not going to run into unexpected merge conflicts and whatnot down the line. Now, GitHub, the service, I guess, is a website basically where that repository is hosted. And not only can you go on there and view the contents of the code, but you can, leave reviews of code, you can leave comments, you can add collaborators, you can remove collaborators if you don't like them, that sort of thing. So we've cloned our Git repository and, we're sort of eager to start making changes, I guess. But before we really do anything, it's worth considering branching, even at this early stage. So every Git repository essentially has a primary branch, usually called main or master, and assuming it's not brand new, it will have had some previous commits on it. Now, as we mentioned before, commits are essentially snapshots of the code at certain points in time, and they're used whenever you want to save your work. We'll see commits very shortly. Now, by default, when you clone a repository, it puts the head on the latest commit of the primary branch. That's what that arrow thing is. It's referred to as the head. And you'll see the word head in Git terminology quite often, usually in capital letters. And honestly, it's simply a pointer telling you exactly where you are in the repository. It's nothing fancier than that. And the idea is that whenever you branch or whenever you make a commit, that pointer follows you around. The reason why it might be useful to know specifically about that pointer is because it can then be used to select specific commits if you want to go back, or if you want to do things like undoing commits and whatnot. It's useful to understand exactly what that is. So the head basically follows you around, I guess. You are effectively the head. When you branch, that will follow you to your new branch. So speaking of branching, the git branch command is what allows you to create new branches. And you might want to do this because it's not often really the best idea for people to be directly committing to that primary branch. Now, the reason for this, the specific reason for this is A, I guess it's a neatness thing. B, it lets other people review your code essentially, rather than you just directly committing it to the primary branch. We'll see later the functionality of pull requests, where you can essentially request to have your code merged into that primary branch. And I guess for a third reason, that primary branch might be connected to some kind of release system. When a commit is made in that primary branch, there might be some kind of process that kicks off that builds that application and uploads it somewhere for people to use, that sort of thing. Now, what we've done so far is only create the branch. To actually switch to that branch, we need to use the git checkout command. So finally, we've got a local repository, and we've created a branch that is branched from the main branch. Law of branching. So now we're ready to make some changes. So the place where our code lives is referred to as the working directory. We're first going to make some changes in that working directory. Maybe we'll edit some code files, maybe we'll create some new ones. Then we're going to use the git add command to stage those changes. Now, what that does is it adds the files that we want to add to the staging area. This area consists of any files that we're going to want to update in our next snapshot, essentially. Now, this doesn't necessarily mean you have to drag your entire repository into the staging area. Any files that aren't in the staging area when you take your snapshot are simply just left untouched. So the staging area deals with only files that you actually want to update in the next snapshot, not necessarily have in the next snapshot, if that makes sense. Now, I guess for your sanity, the git add command can take a path to an individual file, or it can take multiple files by using wildcard notation, like this. Now we take our snapshot, which again is also referred to as a commit. And the commit command requires a commit message, which should be a short description of the changes that are made. Now, you kind of just have to be sensible with commit messages, I guess. You don't want to have something stupid like added file or whatever, but at the same time, you don't really want to write out a short story or something. So just be sensible, I guess, like corrected issue in so-and-so. I don't know. And as we can see, we add a new commit to the branch that we are currently working on. So we've made our changes, but those are currently only in the local repository. Maybe we now want to push our stuff to the remote repository, so that way all our friends and stuff can see our changes. Maybe they will want to visit your branch by using the git checkout command, for example. Now let's assume we've made a series of commits on our branch. There's nothing restricting you from making as many commits as you want, really, again, within reason. And you can make those commits as many times as you want in your local repository before then pushing all of those commits to the remote repository. To push this new branch is quite straightforward. We just use the git push command. Now on the remote repository, we're going to be able to see our newly appeared branch. So let's have a look at what that actually looks like on the GitHub website. So by default, we see the main branch. If I click over here to see all the branches, you'll be able to see one of the branches that we just pushed, for example. I guess something I should point out here is the naming convention of the branch. You see here, I've happened to call it feature/test in this case. So I've designated it as a feature branch with this kind of convention. Now, It kind of depends on your organization, I guess, or your style. Certain branches you might want to designate as something. For example, a feature branch could be when a new feature is added. A hotfix branch could be when like a bug is fixed or something. So that's one particular type of designation that's quite common, I think. By the end of the day, you can call your branch what you like, really, within reason. I think the main thing is just to be consistent, really. Now let's have a look again at what this looks like graphically. Whilst we have pushed our branch, we might be happy with it ultimately, and we want to integrate those changes into the main code base, like this. This is done through some functionality called a pull request. If we go back to the repository page and head to this pull request tab, we can actually create a new pull request. As the name kind of implies, you make a request to pull your code from your branch into the main branch, or any other branch really. When you make the request, it shows you like the diff, which is the changes that would be being made to the main branch if the pull request was merged. And here I've just changed a heading in my Jupyter notebook to make it more heartwarming, I guess. When we make the request, we can add reviewers just to sort of sanity check our code. And from the perspective of the reviewer, you can leave comments and stuff. You could leave encouraging comments, you could leave discouraging comments, kind of up to you, I guess. And you can comment on individual lines and ultimately start this whole formal review thing. If you feel like approving it, you can do so here. Unfortunately, I can't approve my own pull request, sadly. Finally, down here, we can actually merge our pull request. And yeah, I'm not going to do that though. I like my original headings, I guess. So we've just kind of seen the main Git workflow, really. You know, we've pulled down some content from the remote repository, we've branched off, we've made our changes, we've pushed that back to the remote repository, and then we've integrated that back into the sort of main branch, the main code base, if you like. And that's the sort of main workflow, really. Now, there's a ton of other Git commands and stuff that I don't really think most people remember, but when you need a specific thing, you can always look it up, right? So now let's go through an example workflow to see what that would actually look like when you're doing it. So I'm going to assume a little bit of familiarity here with the terminal and any commands we might be running. So currently I'm in a folder on my desktop. You can see that because I run the pwd command, which refers to present working directory. I'm going to use the git clone command that we discussed before to clone my tutorials remote repository. And then that gets cloned down. I'm just going to use some basic commands to essentially browse that file structure and get into exactly where that has been cloned to. So now at this point, I'm in my Git repository. I didn't really mention this before, but the git status command is quite useful wherever you are, really. It tells you what branch you're on, what files have changed, that sort of stuff. Feel free to run it as many times as you like, I guess. And we can see that by default, I'm on the main branch because I just cloned the repository. So let's create a new branch first using the branch command and then check that branch out. I want us to make some changes now to the code base, so I'm going to start by just adding a blank file. That's what the touch command does, it just creates an empty file, and here I'm creating a text file. Now we see that the status shows that it spotted a new file, right? But it's not being tracked. So remember, we need to add a file to a staging area to ensure that it's tracked so that when we take our snapshot, that gets reflected. So let's add that to the staging area using the git add command. I'm then just going to make another file as well and add that to the staging area as well. So we're happy with our changes now and we want to take our snapshot. So the git commit command can do that for us. So finally, we want to push our changes. Now, previously I kind of said it was just as simple as git push. The slight thing here is that the first time you run the git push command, because that branch doesn't exist on the remote repository and it's something we've created locally, by default, Git tries to associate that with a branch that's on the remote repository, and it's like, what the hell is this? So the first time we do a push, we essentially need to set a link saying, hey, this local branch refers to this branch on the remote repository. Thankfully, it kind of just spits out the command that you need, so you can just copy paste that basically, and then for subsequent pushes, you can just use the git push command. And that's it. I think we're done. Now, obviously, like we saw before, you can go on the GitHub page and make a pull request and all that stuff. And that's it, really. So I hope you found that useful, maybe, kinda. If you did or you didn't, feel free to leave any feedback and whatnot. And thank you for watching. I will see you in the next one.